Statistics and probability.
Morning. Today we will discuss about t-distribution. For our competencies, first we need to illustrate t-distribution, and next is to identify percentile using t-table. And now let's start with our first activity. For our first activity, we need to determine the sample size using the formula n is equal to n all over 1 plus n multiplied to the square of e, where our small n is the sample size, and our capital N is the population size, and our e is the sampling error. Here are the situations. First, there are 50 different stores in Barangay Kabangkalan. How many store owners you need to interview for your survey if you plan not to interview them all and you allow a margin of error of 5%. Second, a certain mall has about 200 employees. You need to conduct a survey about employee satisfaction. How many employees you may include as sample if you allow a margin of error of 6%. You can pause and then I'll give you 10 minutes to answer.
A few moments later.
And now we are back for our answers of activity number 1. So what's your answer for number 1? Correct. You need 44 store owners to interview for number 1. How about number 2? Correct. You need to have the 116 employees. So we're done with activity number 1. And now let's have our activity number 2. So for our activity number 2, we are given here two curves. We have curve A and curve B. So what are the similarities of the two curves? And what are the difference of two curves? So you can pause for a while and I'll give you 5 minutes to answer.
A few moments later.
Welcome back. I believe you already have your answers for our activity number 2. So for similarities, I can have an answer of they are both in bell shape. But in number 2, the differences, we can say that curve B is have heavier tails than our curve A, or has a more pointed curve than curve A. So how about your answers? Okay, now let's move on. For our topic, t-distribution. So what is a t-distribution? So when I say t-distribution, it is also known as student's t-distribution, a type of probability distribution that is similar to our normal distribution with its bell shape but has heavier tails. So we have here the normal distribution, the bell shape for the normal distribution that we already have discussed. And this is the example of a t-distribution bell shape curve. So the t-distribution is most useful for small sample sizes that is less than 30. So when the population standard deviation is also not known, or both. So we can use t-distribution if first the sample size is less than 30, and second if the population standard deviation is not known, or both unknown. So we have here, as the sample size increases, the t-distribution becomes more similar to the normal distribution. So furthermore, the concept of degrees of freedom, or the DF, is used in our t-distribution. So the degrees of freedom denoted by DF are the numbers of values that are free to vary after a sample statistic has been computed. And the formula for DF is equal to n minus 1, where n is the sample size. And now let's move on to our third activity. So it will be based on your understanding of the definition of our t-distribution. So here we have to complete the concept map with the term z-score or t-score to be written on the blanks. We have there, do you know the population standard deviation? If yes, is the sample size above 30? If yes, use the blank. If no, use the blank. If no, use the blank. So I'll give you about 2 minutes to answer, so pause for a while and we'll be back.
A few moments later.
Welcome back, and now let's reveal the answers for our third activity. So we have the concept map. Do you know the population standard deviation? If you don't know, if the answer is no, you will use the t-score. Very good, meaning we have the t-distribution for if the population standard deviation is not known. If it is known, is the sample size above 30? So if the sample size is above 30, if your answer is yes, use the z-score. And if the sample size is less than 30, we'll use the t-score. Very good. Let's have our fourth activity. So for our fourth activity, we need to solve the degrees of freedom, wherein our formula is df equals n minus 1 and n is the sample size. First situation, a CEO of battery manufacturing company claims that an average battery lasts 360 days. A researcher randomly selects 25 batteries for testing. Second, the average time for a learner to study is 25 minutes. So you are planning to contact your 20 friends to check their amount of time studying. And third, a student wants to determine the relation of watching cartoons to learning English. So she wants her 10 little cousins, ages from 3 to 5 years old, to be her sample of study. So we'll be given 3 minutes to answer.
A few moments later.
Hello, we're back for the answers of our activity number 4. So, solving the DF for number 1, our DF is 24. Correct. 25 minus 1 is 24. How about number 2? Correct. 19. 20 minus 1 is 19. And last is, very good, 9. 10 minus 1 is 9. You got it all correct. And now, let's move on. Hello, and now I'll be showing you the t-table. So if we have z-table, we have also t-table. So we have here a sample of our t-table. So for our t-table, we have the degrees of freedom in the first column and the confidence level on the first row. And the last row here, we have the one-sided p or one-sided probability and the two-sided p or two-sided probability or area. It could be the area under the curve. And the values in the middle, these are the t-scores or the t-values. Unlike with the z-table, we are looking for the probability at the middle, while the z-scores are on the sides. Here it is different. The values at the middle are the t-scores or the t-values. And now let's have samples or examples using t-table. So we have here the first situation. Find the t-score that has an area of 0.05 to its right for t-distribution with 13 degrees of freedom. So let's try to illustrate it first before we use the t-table. So we have here example of the t-curve. So 0 at the middle. So when you see to the right, so meaning to the right of 0, let's have this. So we can see here, the shaded part is the area 0.05 and the blue line is our t-score. So since we can see here it is at the right side of 0, so we have a positive answer for our t. Using the t-table, so let's look first for the degrees of freedom, which is 13. So that is 13. And then for our 0.05 area, that is one-sided. We can see here that it is only one-sided. So one-sided P of 0.05, it is here. And the intersection of the two is our t-score. So therefore, the t-score is 1.771. Let's have our second example. Find the t-score in the 90th percentile with 9 degrees of freedom. Again, let's try to illustrate it first. So we have here the t curve. So, illustrating it, the shaded part is the 90th, or these are the value below the 90th percentile. That's the shaded part. So, the blue line is our t-score. The unshaded part of our curve is 2%, or 0.02 as our probability. So, using our t-table, so let's look first the 9 here in degrees of freedom. And then, for our area or the one-sided P, we have here the 0.02. So, our t-score is 2.398. So, positive 2.398. Let's have our third example. Find the t-score in 2.5 or 2.50th or percentile for our DF equals 12. So again, let's try to draw using our t-curve. So we have here, as our illustration shows, that 2.5% or the 0.025 is the shaded area or the 0.025 probability. And the blue line is our t-score. Using our t-table, let's look for our 12. So 12 is our DF and our probability is 0.025 and it is one-sided 0.025 and the intersection is 2.179. And looking at our illustration, it is on the left side of 0, meaning it is negative. So therefore, our t-score is negative 2.179. For our fourth example, you want to construct a 95% confidence interval for data based on a sample size of 9. Find the critical values of t. Again, we'll try to draw our situation here. So from our t curve there, so we come up with this form. So here is the 95% confidence interval, the shaded area. And the two blue lines, those are our critical values of t. So we have here on the right side of 0 and the left side of 0, meaning our critical values are positive and negative. Using our t-table, so let's look first for our df. Our df here is 8. Why 8? Because our sample size is 9. So 9 minus 1, it is 8. So now, for our confidence interval or confidence level, we have the 95% above. And then in the intersection is 2.306. So we have here our critical values are negative 2.306 and positive 2.306. I believe you are ready for our fifth activity. For our fifth activity, you need to read the problem and answer the questions that follow. So for our first situation, the 17 students in Kabankala National High School take a special test in statistics and probability. First, determine the value of df. Second, find the t-score that has an area of 0.01 to its left. And letter C, find the t-score in 99.5 percentile. So I will give you about 10 minutes. So pause this for a while and we'll be back for the answers.
A few moments later.
And now let's reveal the answers for our fifth activity. So for the DF, we have 16 because 17 minus 1 is 16. And for our t-score, letter B is correct, negative 2.583. And for our letter C is 2.921. Very good. You did a great job. And now, For our suggestions, comments, and queries regarding our topic, just give your thoughts under comment section or you can directly ask me through Messenger. Thank you very much and see you next topic. Bye-bye.